Hello students, welcome to Aakanksha Science classes. I am Dr. Aakanksha Ahlawat and today we are going to start with first chapter of class 9 science, that is matter in our surrounding. ये काफ़ी इजी चैप्टर है. बचपन से आप सब मैटर एंड इट्स स्टेट्स के बारे में जानते आए हो एंड ऑल्सो हैव लर्नड अबाउट मेल्टिंग पॉइंट, बॉइलिंग पॉइंट. सो आज हम इस चैप्टर को काफ़ी इजी वे में कवर करेंगे. वॉच दिस वीडियो टिल द एंड टू अंडरस्टैंड दिस होल चैप्टर इन जस्ट वन वीडियो. So let's start. What is matter? Everything in this universe is made up of matter. हमारे आसपास जितनी भी चीज़ें हैं, everything is matter. And matter occupies space and has mass, and it offers resistance to any applied force. That if you apply some force on it, it also offers resistance to that applied force. And it occupies space and mass. So हमारे आसपास जो भी चीज़ें हैं, everything is matter. And matter is made up of particles and particles are very small. सभी matters particles के बने होते हैं. If we talk about characteristics of those particles, first characteristic is particles of matter are continuously moving. That is, they possess kinetic energy. Because of movement of those particles, they possess energy, and that energy is kinetic energy. So as the temperature rises, particles moves faster. Because of the rise in temperature, particles थोड़ा fast move करने लगते हैं because kinetic energy of those particles increases. So as temperature increases, kinetic energy also increases and particles starts moving faster. So particles of matter have space between them. So if we talk about solids, liquid and gas, maximum space is in gases and उससे कम space है liquids में and सबसे कम space है solids में. If we talk about space between the particles. So when we make tea, coffee or lemonade, particles of one type of matter get into the space of between particles of the other. This shows that there is enough space between particles of matter. Like if you try to dissolve salt or sugar in water, so that completely dissolves. Sugar or salt completely dissolves in water because the particles of sugar or salt gets into the space between the water molecules. So if you see this figure, these are particles of water magnified millions of times, and if you add salt to it and stir it, you will see that particles of salt gets into the space between particles of water. So we can say that particles of a matter has space between them. Next property is particles of matter attract each other. So particles of matter, be it solid, liquid or gas, there is strong force of attraction between the particles. For example, if you open a water tap and try to break the stream of water with your fingers, so can you break that? No, because stream of water remains together. And why it remains together? Because of force of attraction between the particles of water molecules. So we can say that the space between the particles and kinetic energy of particles is minimum in solids, intermediate in liquids and maximum in gases. More the space between the particles, more is the kinetic energy. So it is maximum in gases, intermediate in liquids and least in solids. The force of attraction between the particles is strongest in solids because the particles are very closely packed, intermediate in liquids and weakest in gases. So because particles are very far away in gases. Movement of particles is minimum in solids because they are tightly packed, so there is very less space for any kind of movement. So movement of particles is minimum in solids, more in liquids and maximum in gases. That's why because of movement of particles, since it is maximum in gases, that's why they have more kinetic energy. So this is magnified image of three states of matter, and motion of particles can be seen. This is solid, this is liquid and this is gas. So maximum motion of particles is in gaseous state, then after that it is in liquids, and least motion of particles is in solid state. So this shows arrangement of particles in three states of matter and their movements. So maximum movement is seen in gases, then after that some movement can be seen in liquids, and least movement is seen in solids because they are tightly packed. So if we see the states of matter, there are three physical states of matter: solid, liquid and gas. And we can classify our body into three states of matter, that is solid, liquid and gas. So if we see our body, then bones and teeth are solids, and blood and water present in our body are liquids, and air in our lungs is gaseous. So now we will see some characteristics of solid state. They have definite shape, they have distinct boundaries, they have rigidity and incompressibility, that you cannot compress it, and they are very rigid, काफी hard होते हैं, and they have definite volume. So they have definite volume because particles are very closely bound, and definite shape है ही, and distinct boundaries, that it has a fixed shape. But some exceptional examples are like rubber band is solid, but it can change its shape under force and regains its shape when force is removed. And if excessive force is applied, it breaks. But rubber is a solid, and it is an exception that it can change its shape under some force. But if you remove that force, it again comes to its original state. But if more force is applied, it breaks. The solids have fixed and rigid shape. The kinetic energy of the particles in the solid state is very less, therefore solids have fixed and rigid shape because particles cannot move. So there is kinetic energy of the particles in solid state is very less. So we can compress sponge, but sponge is solid, but we can compress it because it has pores that are filled with air. So that's why we can compress it. Salt and sugar take the shape of container. Like if you put some salt in different kinds of container, they take the shape of that container in which they are placed, but shape of their crystals do not change. Like shape of one crystal of sugar or salt do not change. So they are solids, but they take the shape of container because if we put as a whole salt or sugar in some containers, they take that shape. But if we talk about one crystal, then that it has fixed shape, so that is a solid. So next state of matter is liquid state. Some characteristics are like they have fluidity. It is the ability of substance to flow easily, that they are not rigid. They show low compressibility. Since there is some space between the particles, they can be compressed. And they have no definite shape and boundaries. इनकी कोई भी particular shape नहीं होती, ना कोई boundary होती है, but they can take the shape of vessel. In whatever container they are kept, they take the shape of that container. But they have definite volume. Volume is fixed. Force of attraction between the particles of liquid keeps its volume same. Because of the force of attraction between the particles, इनकी volume same रहती है. And liquids are substances having fixed volume. इनकी volume fixed है, but इनकी shape fixed नहीं है, and they take the shape of container in which they are stored. And the gases like oxygen and carbon dioxide from the atmosphere diffuse and dissolve in water. ये gases water में dissolve हो सकती हैं. Due to these gases, aquatic plants and animals are able to survive. Diffusion is much more in liquids than in solids due to free movement of particles in liquid. Because there is free movement of particles in liquids and there is some space between the particles in liquid, so gases can easily diffuse in it. And because of this, aquatic plants and animals are able to survive because they are getting oxygen and carbon dioxide. Next state of matter is gaseous state, and some characteristics are they have fluidity just like liquids. They have high compressibility because they have maximum space between the particles, so they can be compressed. They have no definite boundaries. इनकी कोई definite boundaries नहीं है, ना कोई definite shape है, ना कोई definite volume है. The particles in a gas are free to move. They are free to move in any direction, hence gases can flow. Gases are substances that do not have fixed volume and occupy all the volume available to them. So they can occupy all the volume that is available to them. The space between the particles increases, and they can occupy a smaller space as well as larger space. Pressure of gas is the force applied on the walls of vessel by the irregular moving gas particles. Because gas particles are continuously moving, that's why they apply some force on the walls of vessel, and that is the pressure of gas. Now we will see how states of matter change. Water can exist in three states of matter, that is solid as ice, liquid as water, and gas as water vapor. So water can exist in solid, liquid and gas, all three states. On heating ice, it melts into water, and on further heating it converts into water vapors. So change in physical state of matter can be done in two ways. First one is by changing the temperature, and second one is by changing the pressure. First one we will see by changing the temperature, melting of ice to form water. Like if you keep ice at room temperature, or if even if you heat it, it will change its state. It will change its state from solid to liquid. And if you boil water, it will be converted from liquid state to gaseous state, that is water vapors. So this is apparatus showing boiling of water, and this is apparatus showing melting of ice to form water. What is melting point? It is a temperature at which a solid melts to form liquid at atmospheric pressure. Melting point of ice is 0 डिग्री सेल्सियस, एंड 0 डिग्री सेल्सियस को अगर हम केल्विन स्केल पे कन्वर्ट करें तो इट इज़ 273.16 केल्विन. During melting, the temperature of ice does not rise even though heat is being supplied continuously because of latent heat of fusion. So latent heat of fusion is the amount of heat supplied to change the state of ice from solid to liquid without change in its temperature. So latent heat of fusion वो हीट है जो सप्लाई की जा रही है आइस को, so that it converts into liquid, बट उसका टेम्परेचर चेंज नहीं होगा. सो दिस लेटेंट हीट ऑफ फ्यूजन इज यूज्ड अप टू ओवरकम द फोर्स ऑफ अट्रैक्शन बिटवीन आइस पार्टिकल्स. सो ये जो हीट है ये इट इज़ यूज टू ओवरकम द फोर्स ऑफ अट्रैक्शन बिटवीन द आइस पार्टिकल्स, एंड दैट ब्रेक्स इनटू that force of attraction breaks and it converts into liquid state. So at 0 degree Celsius, energy of water particles is much more than energy of particles of ice at 0 degree Celsius. So energy of water particles ज़्यादा है at 0 degree Celsius. That's why it has tendency to be converted into liquid state. So what is latent heat of fusion? It is the amount of heat required to change 1 kg solid to its liquid state at its melting point at atmospheric pressure. 1 kg solid को liquid state में convert करने के लिए उसके melting point पे जितनी heat चाहिए at atmospheric pressure, उस heat को कहते हैं latent heat of fusion. इसमें टेम्परेचर चेंज नहीं होगा. जस्ट दैट हीट सप्लाइड इज यूज्ड टू ओवरकम द फोर्स ऑफ अट्रैक्शन बिटवीन द पार्टिकल्स ऑफ आइस. नाउ नेक्स्ट इज बॉइलिंग पॉइंट. द टेम्परेचर एट विच अ लिक्विड बॉइल्स टू फॉर्म वेपर्स एट एटमोस्फेरिक प्रेशर इज कॉल्ड इट्स बॉइलिंग पॉइंट. जहाँ पे लिक्विड बॉइल करके वेपर्स में कन्वर्ट हो जाता है उसको बोलते हैं, उस टेम्परेचर को बोलते हैं बॉइलिंग पॉइंट. बॉइलिंग पॉइंट ऑफ वाटर इज 100 डिग्री सेल्सियस, और उस 100 डिग्री सेल्सियस को अगर हम केल्विन में कन्वर्ट करें तो जस्ट ऐड 273 डिग्री टू इट, 273 टू इट, एंड इट विल बी कन्वर्टेड इनटू केल्विन स्केल. सो इट इज 373 केल्विन और 100 डिग्री सेल्सियस. इट इज अ बॉइलिंग पॉइंट ऑफ वाटर. व्हाट इज लेटेंट हीट ऑफ वेपराइजेशन? सो यहाँ पे जितनी हीट प्रोवाइड की जाएगी उस लिक्विड स्टेट को कन्वर्ट करने के लिए इनटू वेपर्स, उसको बोलेंगे latent heat of vaporization. So this is amount of heat required to change 1 kg liquid into its gaseous state at its boiling point at atmospheric pressure. इसमें भी temperature change नहीं होगा. Temperature will remain same, just that heat supplied is used to overcome the force of attraction between the particles of water. So during boiling, the temperature of water does not rise even though heat is being supplied continuously, as this heat of vaporization is used up to overcome the force of attraction between water particles. At 100 degrees Celsius, energy of water vapor is much more than energy of water at 100 degrees Celsius. That's why it has a tendency to be converted into gaseous state, that is water vapors. So we can change one state of matter to another state by changing temperature. So you can see this. Solid state can be converted into liquid state by heating, and liquid state can again be converted into solid state by cooling. And liquid state can be converted into gaseous state by heating, and gaseous state can again be converted into liquid state by just cooling it. You can see example of water. If you melt ice, it will be converted into liquid state, but if you again freeze it, it will convert it into ice. And if you boil water, it will be converted into vapors, and if you condense those vapors, it means if you cool those vapors, it will again be converted into liquid state. So water exists as liquid at 25 degrees Celsius, and at 0 degrees Celsius water is solid and exists as ice, and at 100 degrees Celsius water is gaseous state, that is steam. Next important term is sublimation. It is the change of solid state directly into vapors. Solid state can directly be converted into vapors on heating, and of vapors into solid on cooling without passing through the intervening liquid state is called sublimation. So conversion of directly solid state into gaseous state is sublimation. So इसमें बीच में liquid state आती ही नहीं है. Solid state is directly converted into liquid state. एग्जाम्पल देखते हैं. कैम्फर, अमोनियम क्लोराइड, ये दीज आर सम ऑफ एग्जाम्पल्स ऑफ सबलाइम सब्सटेंसेस. अगर इनको चाइना डिश में रख के कवर करें और ऊपर से इन्वर्टेड फनल लगा दें, अभी आई विल शो यू द फिगर, एंड द वेपर्स ऑफ अमोनियम क्लोराइड आर कन्वर्टेड इनटू सॉलिड अमोनियम क्लोराइड ऑन कमिंग इन कॉन्टैक्ट विद कोल्ड इनर वॉल्स ऑफ फनल. सो यहाँ पे इन्होंने लिया है सोडियम क्लोराइड और अमोनियम क्लोराइड का मिक्सचर, एंड they have heated it, and जो ammonium chloride है, it is sublime substance, so it will be converted into vapors, gaseous state, and on coming in contact with the cool surface of funnel it will be deposited, and sodium chloride china dish में ही रह जाएगा, whereas ammonium chloride will be deposited on the surface of the funnel. So this is showing the sublimation of ammonium chloride. Now we will see effect of change of pressure. हमने अभी temperature का effect देखा. Now we will see the effect of change of pressure. If we compress a gas in a cylinder, the distance between the particles of gas is reduced. अगर हम गैस को एक सिलेंडर में कंप्रेस करें तो पार्टिकल्स के बीच का गैप कम होता जाएगा, एंड फाइनली गैस इज लिक्विफाइड ऑन लोअरिंग द टेम्परेचर. और अगर थोड़ा सा टेम्परेचर और लोअर करें तो वो जो गैस है वो फाइनली लिक्विड स्टेट में कन्वर्ट हो जाएगी. लाइक यू कैन सी इन दिस फिगर, दे हैव कंप्रेस्ड द गैस एंड द मॉलिक्यूल्स स्टार्ट कमिंग टुगेदर, एंड फाइनली इट कन्वर्टेड इनटू gaseous state. So by applying high pressure, the particles of gas can be brought close together. Solid carbon dioxide, it is also called dry ice, is changed into carbon dioxide gas directly without changing into liquid when pressure is reduced to 1 atmospheric pressure. So जो dry ice है ये directly carbon dioxide gas में convert हो जाती है बिना liquid state में आए, अगर प्रेशर रिड्यूस किया जाता है 1 एटमॉस्फेरिक प्रेशर से. सो द स्टेट्स ऑफ मैटर दैट इज सॉलिड, लिक्विड एंड गैस आर डिटरमाइंड बाय टेम्परेचर एंड प्रेशर. सो ये जितनी भी स्टेट्स हैं ये बेसिकली डिटरमाइन की जा सकती हैं टेम्परेचर और प्रेशर से. अगर हम इनको चेंज कर दें टेम्परेचर और प्रेशर को तो स्टेट ऑफ मैटर ऑल्सो गेट्स चेंज्ड. सो यू कैन सी हेयर सॉलिड इज कन्वर्टेड इनटू लिक्विड बाय फ्यूजन. इसका मतलब है हीट करेंगे तो वो लिक्विड में कन्वर्ट हो जाएगा, और दैट लिक्विड कैन बी कन्वर्टेड इनटू सॉलिड बाय सॉलिडिफिकेशन, मतलब उसको फ्रीज करेंगे तो वो सॉलिड में कन्वर्ट हो जाएगा. लिक्विड कैन बी कन्वर्टेड इनटू गैस बाय हीटिंग इट, मतलब वेपराइजेशन बोलेंगे क्योंकि द गैस विल बी कन्वर्टेड इनटू वेपर्स फॉर्म. एंड गैस को अगर हम कंडेंस कर देंगे मतलब कूल कर देंगे तो दैट अगेन विल बी कन्वर्टेड इनटू लिक्विड. एंड सॉलिड कैन बी कन्वर्टेड इनटू gaseous state by sublimation without coming in liquid state. And gas can be converted to solid by deposition because that gaseous state comes in contact with the cool surface and it gets deposited. So next important term is evaporation. Evaporation क्या है? It is a surface phenomenon in which liquid changes into vapors. जो liquid होता है वो vapors में change हो जाता है at any temperature below its boiling point. तो उस liquid को boiling point तक heat करने की ज़रूरत नहीं होती. It gets converted into vapors below that temperature. तो इस process को बोलते हैं evaporation. Particles on surface of liquid have higher kinetic energy than others. So जो surface पे particles हैं liquid के उनकी kinetic energy ज़्यादा है. So they break the force of attraction between the particles and escape from the surface of liquid in the form of vapor. So जो particles जो surface पे हैं they have a tendency to go in the vapor state. So they break the force of attraction between the particles and get escape. सो इस प्रोसेस को बोलते हैं इवेपोरेशन. सो इवेपोरेशन कई सारे फैक्टर्स पे डिपेंड करता है. सो these are 4 factors which affect evaporation. First one is exposed surface area. If we increase the surface area, evaporation also increases, and on decreasing the surface area, evaporation decreases. And next is increase in temperature. If you increase the temperature, evaporation also increases because kinetic energy of particles increases on increasing the temperature. So they have tendency to escape. That's why on increasing the temperature, evaporation increases, and on decreasing the temperature, evaporation decreases. Next factor is humidity. Humidity is बेसिकली डिग्री ऑफ डेम्पनेस ऑफ एयर, मतलब एयर में कितने वाटर मॉलिक्यूल्स हैं. सो हायर द ह्यूमिडिटी लोअर इज द इवेपोरेशन. सो व्हेन द ह्यूमिडिटी ऑफ एयर इज लो, इवेपोरेशन रेट इंक्रीज हो जाता है. सो मोर ह्यूमिडिटी मीन्स लेस इवेपोरेशन एंड लेस ह्यूमिडिटी मीन्स मोर इवेपोरेशन. एंड नेक्स्ट फैक्टर इज विंड. व्हेन विंड स्पीड इंक्रीजेज, अगर हवा तेज स्पीड से चल रही होगी तो इवेपोरेशन का रेट भी इंक्रीज हो जाएगा. एंड इफ स्पीड ऑफ विंड इज लो और देर इज नो विंड, देन रेट ऑफ इवेपोरेशन ऑल्सो डिक्रीजेस. सो इवेपोरेशन ऑलवेज कॉजेज कूलिंग. जब भी इवेपोरेशन होगा तो वहाँ की उस सरफेस की कूलिंग होगी. So the cooling caused by evaporation is based on fact that when a liquid evaporates, it takes latent heat of vaporization from surrounding, which on losing heat gets cooled. So जो liquid है वो evaporate होगा तो वो कुछ heat लेगा तभी evaporate होगा. So it takes latent heat of vaporization from the surrounding, and जो surrounding heat lose करेगा, so that surrounding becomes cool. And that liquid gets converted from liquid state to vapor state. So ये कुछ examples हम देखेंगे, they are very important, you have to keep in mind. and उसको evaporation और latent heat of vaporization से connect करते हुए you have to keep this fact in mind that when we put acetone on our hand, जब हम अपने पाम पे एसीटोन रखेंगे, इट गेट्स वेपराइज्ड बाय टेकिंग हीट फ्रॉम आवर हैंड एंड आवर हैंड फील्स कूल. सो ये जो एसीटोन है हमारे हैंड से लेटेंट हीट ऑफ वेपराइजेशन लेगा एंड इट गेट्स कन्वर्टेड इनटू गैसियस स्टेट और हमारे हैंड को ये कूलिंग इफेक्ट देगा. नेक्स्ट इज वी शुड वेयर कॉटन क्लोथ्स इन समर टू कीप अस कूल एंड कंफर्टेबल, because as cotton is a good absorber of water, so it absorbs the sweat from our body and exposes it to air for evaporation of sweat, thus cools our body. So जो cotton cloth है वो good absorber of sweat है and then it takes latent heat of vaporization from our body and that sweat gets evaporated and giving us cooling effect. नेक्स्ट इज ऑफन पीपल स्प्रिंकल वाटर ऑन ग्राउंड ड्यूरिंग समर. समर में लोग घर के बाहर पानी कि स्प्रिंकलिंग करते हैं बिकॉज दिस वाटर टेक्स हीट फ्रॉम ग्राउंड एंड सराउंडिंग एयर टू इवेपोरेट. वो वहाँ से लेटेंट हीट ऑफ वेपराइजेशन लेगा एंड इटसेल्फ गेट कन्वर्टेड इनटू वेपर स्टेट, और वहाँ की ग्राउंड और एयर को, आसपास के एयर को कूल कर देगा, thus making that place cool. That's all for this chapter. This chapter is complete. I hope you like this video, and thanks for watching. Please like and share this video and subscribe to my channel. Thank you.